Hello everyone, I hope you are doing well. So in today's video, I'm actually going to go through the 2017 Specialist Maths Exam 2 paper extended response questions. And like always guys, before I start this video, if you guys want private tutoring in specialist methods, physics or chemistry, you can always email me through this email. Guys, we have an announcement to make. We have just currently launched our website NVCE Education, and the link will be in the description. And what we're doing there is we are pretty much selling notes. We currently have some physics notes currently available there. They are very comprehensive and very detailed for the new study design. I've pretty much written them. If you guys want to check them out and have a look at them, you can always go there. We've also put some practice papers there, especially for physics, and hopefully in the future we can put some specialist methods and some chemistry papers. They are very cheap, so if you guys want to check them out, please go. Go have a look at it. The link will be in the description. So yeah, guys, let's smash through this paper. So, question 1. Let f be this, where f of x is this function, where d is the maximal domain. Find the equation of any asymptotes of the graph. Okay, when we get a graph like this, what do we know? Straight away, we can find the vertical asymptotes by letting the denominator equal 0. For example, 1x to the power to 3 equals 0. So we get x to the power 3 equals negative 1. So x is equal to negative 1. That is an asymptote. And so this is kind of hard to decompose because, well, this cannot be divided by that. So what is our, do we have any y asymptotes? Well, let's think. Imagine that this goes to infinity. For example, if this goes to infinity, what is the asymptotic behavior? So if we put as x approaches infinity, what happens? Well, we have infinity on top over 1 plus infinity to the power of 3. Now, which one will dominate? Absolutely, the bottom one will dominate because it's larger. So imagine like you're writing it as like 1 over infinity, which is just equal to 0. So hence, in the long term, as x approaches infinity, the graph, the y values will approach 0. Hence, we have an asymptote at y equals 0. So that is that. You can also, just go on your graph and graphing CAS and just graph it, and you can easily find that. So that's not too bad. Find f dash of x and state the coordinates of any stationary points of the graph of f correct to 2 decimal places. Not too bad. Let's do that in our calculator. So let's actually define it. So f dash of x is x 1 plus x to the power of 3. And so we want to find the derivative. So f of x. And we also want to solve answer equals 0, comma x. And we get this coordinate over here. And what's f of that? That's your y coordinate. So let's write all of them in our paper. So f dash of x is going to be negative 2 x to the power of 3 minus 1 all over x to the power 3 plus 1 squared. And f dash of x equals 0 for stationary points, hence what is our coordinate? Well, going down here, we get to 2 decimal places, we get 0.79 and 0.53. And that'll be it. Yeah, those are two decimal places. Nice and easy. All right. Next question. Find the coordinates of any points of inflection of the graph of f corrected to 2 decimal places. 2 marks. Okay, so let's do that. To find the stationary points, it's f dash double dash equals 0. Let's do that. Let's just go actually on here and just write what's f dash of x, and we get this. So let's write that down. So f dash of x, your double derivative, is actually equal to 6x squared x to the power 3 minus 2 all over x to the power 3 plus 1 to the power 3. And that actually just equals 0 for the coordinates, to find the coordinates of the point of inflection. So what happens? We'll get, this cancels out with 0, so that's just, we get x equals 0, and x is equal to So x to the power of 1/3 pretty much. That will be, yeah. We'll cancel that with that one. Yeah. So these are your two coordinates. Now we need to have a look at this. We need to be careful. This is where they take marks off you. Okay, look at this coordinate over here. If I was, kind of, sketching this, what do we see? Like, imagine just having a look at this. So remember, to have a point of inflection, there must be a change in sign. For example, if I had this number over here, I don't even know what the hell this is. So, like, don't even know. Let's actually write it. What's 2 to the power of 1/3? It is actually just 1.25. So this is approximately 1.25. So this is what you need to be careful. You need to have a look at if it changes sign. If it changes signs, then it is a point of inflection. If it doesn't change sign, it's not a point of inflection. And what do I mean by that? For example, if I have this over here, take this for example. If I have this, and if I something like, for example, 8, x equals 8. Well, no. So pretty much what I'm saying is, like, imagine this over here. What are the values between it? Let's say one value is 2, and the other value, let's say, is 0. Those are the values between it. So, for example, let's just draw a timeline here. This is 1.25. And what other values? So we have 2 and we have 0 that is between them. Do they change signs? For example, if I subbed in 2 into this, what happens? So 2 to the power of 3, which is 8, plus 6. So it's actually a positive because it's plus 6. And what about, and here is 0, by the way, because if you sub in 1 point, it's actually 0. What about if you sub in 0? If you sub in 0, it'll become -2. Can you see how there's a change in sign? For example, in between it, there's a negative and positive. This tells us that this point here is an actual point of inflection. Now let's use that test to test 0 works. Let's check it. Now if I put 0 in here, for example, this is 0. Let's say choose 1 and let's choose -1. If I put 1 over here, it will become positive, plus 6. So positive. If I put -1, it gets squared, which is still positive. Now this is a problem. Here is actually not what we call a point of inflection. So yeah, it's actually a stationary point. So pretty much, yeah, not even a stationary point. Yeah, pretty much it's not a point of inflection. That's a way you can test. If you, by the way, one of the tips is the examiner's trying to test you is have a look at always your f double dash of x. Never just let it equal to 0. Look at the equation. If it has something that's x squared, we should always know that it's not going to change sign. So we're going to exclude that as a point of inflection. So that tells us that x equals 0 is not an actual point of inflection. So let's just rub that out. And let's use our calculator to find the exact. So if we go to, what did we get? So, all right. So to go this, double derivative of f of x equals 0, equals 0. And we solve answer, comma, x. We get these two, so, okay, what's f of this one over here? And that gives us this. So let's write that into the coordinates into decimal, 2 decimal places. So we'll get 1.26 and 0.42 pretty much. Yeah, so 1.26 and 0.42. Those are two decimal places. That's it. Next question. Sketch a graph of f of x, this, from x equals -3 to 3 on the axis below, marking all stationary points, points of inflection and intercept with axes, labeling them with their coordinates and show any asymptotes and label them with the equation. So straight away we know that there was asymptote at x equals -1, so let's draw that. At x equals -1 and at y equals 0. Let's do that. Y equals 0. And we've labeled those. Let me just put this over here. There we go. And so let's just use our CAS to look at how it looks. And so f of x between -3 x to 3 that, and we also want to go to Windows Zoom, Windows settings. So X-min will be -3. This will be 3. They will all go by 1. The X scale, the Y scale will be -2, 2, and they go by 1. And this is over here. If you look over, go to View, Grid, Lined. This is the same scale to what your graph on the paper looks like. So just copy and paste whatever this looks like. So let's do that. So this is going to do for a graph. So we can see that it looks like it passes through here. Let's nicely draw. Passes through here. Sorry. So it nicely passes through here. And it passes through 0. It passes through quite in the middle point over here. Passes through down here. And it goes downwards. Okay. So it will look like this. Goes down here. And it goes like that. Pretty much. Yeah. That's how the graph looks like. And now let's label some stuff. So we have 0, 0. That's your axle intercept. We also need to label our stationary point. So we have a stationary at 0.79. So this is our stationary point here. So 0.79, 0.53. 0.53. We're also going to have a point of inflection over here. So let's label that. So the point of inflection is 1.26. So 1.26, 0.42. And yeah, so have we done everything? So mark the stationary points, points of inflection, intercepts, label with their coordinates, and yeah, we've pretty much done everything. That's good. Next question. The region S is bounded by the graph of F, the axis and the line x equals 3. So let's actually copy this, for example. Let's take a screenshot of this. Let's take a screenshot of this and really visualize what the question's asking us. So bring it over here. So over here, so it's telling us that the region S is bounded by the graph of F and the x-axis and the line x equals 3. So x equals 3 is here, this line here. So we have this line that passes through here, which is x equals 3. And the x-axis, so imagine this whole x-axis, and that is bounded. So this whole area down here. So that area is rotated about the x-axis to form a solid revolution. The line x equals a, where a is between 0 and 3. So imagine this whole thing over here is just pretty much rotated about the x-axis and it forms a solid revolution. And the line x equals a, where a is between 0 to 3, so a could be only between these values over here, divides the region S into 2 regions such that when the 2 regions are rotated about the x-axis, they generate 2 solid equal volumes. So for example, there's a line, x equals here, x equals a, that when this region here gets rotated and we found the volume over here equals this volume over here that is rotated over here. So, okay. Write down an equation involving definite integrals that can be used to determine A. All right, let's do that. So that's not too bad. So if I put this over here. All right, so let's actually just find the integral, like find the area that's going to be rotated when rotated. So this area over here will equal it to be this area because they should be equal. So let's do that. So it'll be pi integral from 0 to a. So 0 to a. Because we are rotating about the x-axis, so it'll be dx. And what's y squared? Y squared, which in this case is just f, it will be f dash of x. So what's sorry, so f of x all squared, pretty much, is over here. So that will give us that area, and that area should equal to pi integral from a to 3. Again, f of x, sorry, dx. Pretty much that's what it should equal, and this actual thing over here should give us the value of a. And yeah, Next question, hence find the value of a correct to 2 decimal places. Easy. So let's do that. So let's write that. So pi times the integral from 0 to a of f of x all squared dx. Pretty much copy this whole thing. Equals, but now this is a and this is 3. Enter and we solve answer a. And we get a as this. So a to 2 decimal places is 0.98. So a is 0.98. That's all right. That's not a bad question to write. Okay. Question 2. A helicopter is hovering at a constant height above a fixed location. A skydiver falls from rest for 2 seconds from the helicopter, but skydiver is subjected only to gravitational acceleration and air resistance is negligible for the first 2 seconds. Let the downward displacement be positive. So let's actually have a sketch of this. So imagine this guy jumps off a helicopter. Let's make him a ball, actually. Just make him a ball. He pretty much jumps off the helicopter at u equals 0, where velocity is 0 because he was at rest. And he's only subjected to gravity, which in this case is 9.8. And because we are taking down as positive, this over here is normally negative 9.8, but because downwards is going to be positive, we're going to leave it as 9.8. And what else? It takes him, he falls down, and yeah, he falls down for the 2 seconds, and he comes over here, and it takes how much? It takes 2 seconds for him to reach over here. It falls from rest 2 seconds from the helicopter, so only to gravitational, air resistance negligible. Find the distance. So we just need to find the distance, this distance over here. And that's not too bad. We can just use our Suvat formulas. So let's do that. We want to find the distance, so we want to find S. Okay. What formula would we use here? We would use, if I'm not mistaken, S is equal to UT plus half AT squared. Where S in this case is, U is just 0, so it just becomes half. What's our A? A is 9.8. And what's our T? So T squared is just 4. And yeah, let's write that down in our calculator. So we're saying 0.5 times 9.8 times 4. That gives us 19.6. So your displacement is 19.6. So that is the displacement down there. Great. Next question. Show that the speed of the skydiver after the 2 seconds is 19.6. So now we want to find the velocity also now. So we want to find the velocity after. So, okay, so now we have enough information. So we have u equals 0. A is equal to 9.8. T is equal to 2. And we just want to find velocity. Now, using the formula by using Suvat, v equals u plus at, velocity, well, u is 0. It's just acceleration times time. Which in this case, times 2, actually. Why did I write a question mark here? So, and that overall will give us 19.6 meters per second. Yeah, so we've shown how to get that. After 2 seconds, air resistance is significant and the acceleration of the skydiver is given by this. Find the limiting or terminal velocity in meters per second that the driver would reach. So, okay, terminal, what does that word mean? It means that the acceleration is 0, or F net, the net force is 0. So think about it. Imagine he's right over here. It's like a ball. The person's a ball. I like to just make it very basic. So imagine he's this ball, and the forces that are acting on him is gravity, his weight. We call, what's his weight actually? Well, they don't give it. Just say call it weight force. And he will also have what we call the force of air resistance. Let's call it R, resistance. Now, in terminal velocity, these are equal. It means that he's actually not accelerating. So the net force is just 0. So acceleration 0. So if acceleration 0, we just have to sub in 0 in this formula. So it will be 0 equals g minus 0.01 v squared. Hence, what's v? Let's use our calculator. So we're saying 0 is equal to g minus 0.01 times v squared. and we want to solve answer comma b. And we get 2, but of course, velocity in this case, because we're, so it says, what, find the limiting velocity. It will be this one over here. Right over here, v equals 10 over root g. 10 over root g. It cannot be the other one, as we are taking velocity downwards. And yeah, so velocity will go downwards. I mean, our motion is going downwards anyway, so velocity must be positive. Meters per second. That is your terminal velocity. That's good. Next question. Write down an expression involving a definite integral that gives the time taken for the skydiver to reach a speed of 30 meters per second. So write an expression involving a definite integral that gives the time taken for the skydiver to reach a speed. So okay. So he just imagine that in this case he falls down, yeah? For 2 seconds. Remember the 2 seconds, he's actually only subject to acceleration negative 9.8, and we know that the time it took him was 2 seconds. So it took him 2 seconds to go over here, and then after the 2 seconds over here, like imagine going downwards, he then gets subjected to air resistance. So this over here, we just need to find the time. So how do we do that? Well, let's think. Acceleration, this formula, acceleration, because we're writing a definite integral, acceleration can be written as dv dt. Now this expression also deals with t. This is the one that we want, the time, is equal to g minus 0.01 v squared. And if we kind of rearrange it, so like reciprocate it, dv is just 1 over g minus 0.01 v squared. So this. And now it's easy because if we just integrate it, it will give us the time. Integrate, but in terms of dv, so 1 over g minus 0.01 v squared. It's actually very small, so let me make it very big. So that 1 over g minus 0.01 v squared dv. And what are the velocities? We're going to, well, what is this velocity over here to this velocity over here? Now, we know that the end velocity is 30 meters per second, as it's told in the question. So we want to go to 30 meters per second. And what is our velocity over here? So after that 2 seconds, we did solve it, which was the speed, 19.6. So 19.6. Now, okay, this will give us this time over here. But remember, we want the total time, the actual expression for the time taken for the skydiver to reach that speed. So we also need to add this too. That will give us the total time, the overall time it took him to reach that speed. So yeah, that's your expression. Let me rub that out. And here's a nice expression. All right, there we go. Next question. Hence, find the time in seconds taken to reach a speed of 30 meters per second to the nearest 10th of the second. Okay, just evaluate this integral. Nice and easy. So let's evaluate this integral. So integral from 19.6 to 30, 1 over g, which is 9.8, minus 0.01 v squared v plus 2. And we get this over here, which is, to the 10 seconds, 5.8. So let's write down. Time is 5.8 seconds. That's it. Nice and easy. Question E. Write down an expression involving a definite integral that gives the distance through which the skydiver falls to reach the speed of 30 meters per second. This distance gives you answer in meters. Okay, so it's pretty much the same diagram that we use. Imagine that, okay, he's over here. He starts with u equals 0, and he goes down. This is when he's subjected for 2 seconds, which is just acceleration, and then after he gets through air resistance. This part over here is air resistance, whereas this part over here is just... Okay, so... Alright, we just need to find the total distance pretty much. But luckily we know this distance over here. Remember, we just calculated that. That was 19.6. That's 19.6. And what about this distance? We need to calculate that distance. So we need to get an expression in terms of a definite integral that can give us that. And, well, what can we do with this acceleration? A equals g. Let's write that down. So A equals G minus 0.01 V squared. Let's have a look at it again. Is that right? Yes. Okay, how can we get it in terms of x? We want x, which is the distance. So what formula that comes to mind? Well, if you look at your formula sheet, you should see this formula. V dv dx. Now, this formula is great because it relates v with x, which is the position, and that's great for finding the distance. So, which this is equal to g minus 0.01 v squared. Okay. And so if I divided, v by both sides, we get dv dx is equal to g minus 0.01 v squared over v. Hence, if we kind of reciprocate it, dx dv is just v over g minus 0.01 v squared. And now it's great because now if we just integrate this, we get the distance. So x, which is distance, will be the integral of this overall thing. So v over g minus 0.01 v squared dv. And so what are these terminals? What are the velocities? So remember, we want to get to 30. So this will be 30 over here. Oh, sorry, that's not, yeah, it'll be 30 on top. We want to get to 30. And what's this velocity over here? I believe, again, it was 19.6. Show the speed of the 19.6. So, okay, 19.6. So this will give us this distance now. And we just have to add it with this. So with this integral, we don't want to forget that 19.6. And pretty much that's it. That will give us the distance, the total distance for the to reach that. That's all. That one's great. All right, let me just take this. Actually, let me take this, put it right over here. And that's it. Next question. Question 3. A bridge is designed using an inverse circular function to make the shape shown in the diagram below. The edges of the bridge in the first quadrant are described by these piecewise. So these here, these just describe this first quadrant thing over here. Okay. Okay, what do we do? Write down the coordinates of the corner point of the bridge in the first quadrant. So we want the coordinates of this. That's not too bad. Well, from 0 to root 2, so this one to this one is 3 arc sine. And then from root 2 to 2, so from here, so pretty much that to that, is 3 arc cos x over 2 from root 2 to 2. So this here should be root 2. So that is the x coordinate. And because they are continuous, not continuous, but yeah, I'll just sub in root 2 into this equation over here. And that should give me the y value. So let's do that. So what's 3? So sine inverse of root 2 over 2. That gives you 3 pi over 4. So it will be 3 pi over 4. Let's write that down. So 3 pi over 4. That's it. That is the coordinates of that first. That's not too bad. Next thing, specify the piecewise function that describes the edges in the third quadrant. So we need to specify, so this one over here. We want to get these ones over here. Well, what we can do, how do we get them? So let's look at the first part here. Let's aim for this first. Let's aim for this part over here. Well, if we know that from here to here, this whole function, it's actually just, which is that 3 arc sine x over 2. You know what's happened to it? It's just reflected along the x-axis. So imagine it's reflected along the x-axis, and this is what it becomes. So imagine that. And then it's actually also reflected along the y-axis, and then it becomes this function over here. So that's great. So pretty much what we're saying is, if we were defining a piecewise function, for example, let's say f of x, the piecewise function would be this over here, but we have a negative 3 arc sine, that reflection along the x-axis and also y-axis. So we'll have a negative x over 2. And now what's happened to the domain? Well, the domain now is here. So it's negative root 2 and to 0, pretty much. So yeah, So we can write it as negative root 2 x to 0. And yeah, so that looks great. Next one is, I think, the same thing. Well, let's look at it. Have a look at the next one. It's this over here. So originally it was this. Imagine it's reflected along the x-axis. Now it's become this. And then if it's reflected along... Okay, so same thing pretty much. Everything is the same. So we can just say negative 3 arc cos of negative x over 2. Now what happens to these endpoints? So we got negative 2 to negative root 2. Negative 2, negative root 2. Now we need to be careful with one of them. One of them is going to, of course, be... Well, in the original question, the arc cos, that root 2 was not included. So in this question, we're not going to include this one over here. There we go. So yeah, these are your piecewise function. I hope that's right. Yeah. Given that each unit in the diagram represents 1 centimeter, find the area of the brooch. Give your answer in square centimeters correct to 1 decimal. So we want to find, given that each unit in the diagram represents 1 centimeter. So, okay, so what does that tell us? Well, it tells us that, for example, this is 1 centimeter, this is 2 centimeters. So, okay, each unit's that. Given that each unit represents 1 centimeter, find the area. Okay. Well, if I just find the area, for example, for this over here, and also this over here, and then times them by 4, wouldn't I just, yeah, that will give me the area of all of them. Okay, so it'll be the area, so the integral of the negative 3 arc, so negative 3 arc sine of x over... Oh, no, not negative, sorry. The original function, so 3 arc sine x over 2 dx, and we're taking it from 0 to root 2. 0 root 2, yes. And we're going to plus the integral from root 2 to 2 of 3 cos, so arc cos x over 2 dx. And yeah, so this will give us this overall area, and imagine get times it by 4 to get the overall area. So this whole expression times it by 4 will give us what? Given that it's trying to find the area. Okay, so area would be, let's use our calculator. So it's 4, pretty much the integral of, let me put that there. So 0 root 2 of 3 sine inverse x over 2 dx plus the integral from root 2 to 2 3 arc cos, so just cos inverse x over 2 dx. And that gives us this over here. And yeah, it's been multiplied by 4, and that's it. So that overall, correct to 1 decimal place, is 9.9. 9.9 units squared. Done. Next question. Find the acute angle between the edges of the brooches at the origin. Give your answer in degrees. So we want to find the angle between the edges at the origin. So this is the origin. Now, these are between the edges, and also this is between the edges. But the problem this is not an acute angle. This is an actual obtuse, because it's greater than 90 degrees. So this here is our actual, this is what we want to find, this theta over here. Well, look, it is a straight line, which makes our life 10 times easier, because we can find those angles, actually, by using their gradients. So, for example, how many marks is the question? 3, of course. So there's going to be some work done. But, for example, if I can find the gradient of this at the point 0, for example, I already know the equation is arc sine, and imagine finding the derivative and subbing x equals 0. We actually get the gradient, and if we use tan inverse of that gradient, we actually get the angle, this angle over here. So that's going to be useful. And okay, let's think about it. If we get the angle, because of symmetry, what we know is that that over here should be equal to that angle over here. And so if we want to find this, it's just going to be 180, so this whole straight line, minus those. So let's try that. So again, let's think about it. So we're going to find the derivative, so d dx, of the straight line, which is 3 arc sine, so let's write that down, 3 arc sine x over 2, given when x is equal to 0. And that is going to give us our gradient. Let's do that. So we're saying derivative of 3 sine x over 2. And that gives us this. And we're saying that when x equals 0, it gives us 3 over 2. So our gradient is actually 3 over 2. So let's write that down. Now, we know that tan of theta is actually equal to the gradient. So we can say that tan inverse of 3 over 2 gives us theta, the angle between the horizontal. So let's use our calculator. So we're saying that tan 3 over 2, which gives us this number over here. And we want to make sure that this is in degrees, times 180 over pi. And that angle is 56.3 pretty much. So theta is 56.3 degrees. What does that tell us? Well, it tells us that this angle is 56.3. Now, because of symmetry, also this one here is 56.3. And we just need to find the acute angle, which is this angle over here, which is 180 minus 2 of these over here. So that's great. So we can say 180 minus, so what's 56.3 plus 56.3? That'll give us our angle, which our angle is what? Let's do our calculator. So we're saying 180 minus this over here. Oops, that was not supposed to be there, but here. Plus another one, enter, and we get 67.38. So correct to one decimal place, that's 67.4. 67.4 degrees. That's it. Nice and easy. Yeah, that's it. That's all they ask. Okay. The perimeter of the breach has a border of gold. Show that the length of the gold border needed is given by this definite integral in this form. So from 0 to 2, that, where a and b are elements of order, let's find the values of a and b. So pretty much if we're finding the perimeter, it's just finding the length of the curve, which is the arc length. And yeah, so we're just trying to find the length of this, the width, this, and that. Okay, so what I'm going to do is think about it. So I'll just find the length of this over here, just this length, and multiply it by 4. It'll give us this length, and this length. And I'll also find the length of this and multiply also by 4, which gives us this length, and this length. So it will give us the total perimeter. So let's do that. So we know arc length. So arc length will be, it's the integral. Let's do the first one. From 0 to root 2. So 0 to root 2. We know the form is 1 over f dash of x squared. That's the form actually that's written. So but our f dash in this case would be, let's use our calculator. Our f dash in this case will be 3 arc sine of x over 2. So this is that. So we're saying, what is the derivative of 3 times arc sine x over 2? And then we also want to square it because it's squared f dash of x, so this squared. And it gives us this, so let's write that down. So pretty much take that plus because we have a minus over there. So minus 9 over x squared minus 4. Okay, dx. So that will give me that. Arc length of this, and we're going to multiply them by 4, by the way. 4. And actually, why don't we just multiply? Yeah, multiply by 4. Plus 4 times, now from root 2 to 2, again, it's 1 plus f dash of x, which in this case, f dash of x would be through our cos. So let's redo our calculator. So this over here, what's 3 times cos inverse x over 2? We get this, and we're just squaring it. We get negative 9. It's pretty much the same thing. Negative 9x squared minus 4. Okay. Dx. Let's take a common factor of 4 out, so like 4 from each. But look, have a look at this. I want you to really look at what I'm seeing over here. So if I kind of take the 4 over here, because we both have 4, so I'll just take 4. Take that 4 over here. If I look at this, they both have the same function. So let's think about it. Imagine that the function f of x was, in this case, this whole function over here. Imagine that, okay, we're finding the area, because we're saying from 0 to root 2. Imagine, so from 0 to root 2, let's say the function looks like this. And this is 0, and here is root 2. And because it's the same function, so imagine it just continues, we're saying from root 2 to 2, so from root 2 to, let's say here is 2, is this area over here. Now, why don't we just put them all together and just make them one function from 0 to 2? Because they're the same function. We can write this whole area as 0 to 2 f of x dx. So let's do that. So bring that 4 still there. But now the integral from 0 to 2, 1 minus 9 x squared minus 4 dx. There we go. See? So we have this, and okay, because that 4 has to be inside because it's not actually over here. So if we bring that 4 inside, we're going to get 0 to, if we bring it inside the square root, we have to multiply everything by 16. So this will be 16 minus, what's 9 times 16? So 16, 9, 54, 9, 10, 11, 12, 13, 14, 144. So it'll be 144 over x squared minus 4 dx. Okay, closely done. Yeah, I think we've got it in that term, have we? No. So this one is 4 minus x squared, and we got x squared. So if I just kind of swap these around, take a minus out, we get 4 minus x squared, and this will become positive. So that's it. That's in that form. So what are your values? So A, in this case, is what? 16. B is 144. Done. That's not too bad. That's it. Question 4. Express this in polar form. Look, I'm going to be honest, just doing your CAS calculator because it's only 1 mark. So I'm just going to control N this whole thing over here. And okay, so the way you would do it is first write the expression. So negative 2 minus 2 root 3 I. And we just want to go menu, number, complex number tools, and go to convert to polar, enter, and we get in polar. So this is your radius, the R value, and this is your angle. Just forget the I, just negative 2 pi on 3. Let's write that down. So we can say that negative 2 minus 2 root 3I is just equal to 4 cis negative 2 pi over 3. That's it. Show that the roots of this are these two. Okay, the most easiest, quickest way is using the quadratic formula or just complete the square. So I'm just going to complete the square because this 4 is a nice, beautiful, easy to use to complete the square. For example, I'll just say, so z squared plus 4z plus 4 minus 4 plus 16 equals 0. So not x, z plus 2 squared plus 12 equals 0. So z plus 2 squared is negative 12. Z plus 2 is equal to plus or negative. Negative, so the square root of negative 12 will be 2. So that's 4, 8, 12. So this, so hence z, don't forget the I, because it was negative. Hence negative 2 plus or negative 2 root 3i. And we've just shown that. Yeah, that's easy and done. Express the roots of this in terms of this. So we want to express them in those. So, okay, let's look at the first root. So I want to separate them actually. So the first root is what? Negative 2 plus 2 root 3i. And the other one is negative 2 minus 2 root 3i. So, so the first root, how can we express it? So the negative 2 plus 2 root 3i can be expressed as, in terms of this, is what? It's just a minus of that 2 minus 2 root 3. Pretty much. Yeah. That's the way. What about the next one? So negative 2 minus 2 root 3i. So if, for example, if we put a minus, so it'll be a minus, but it'll be a conjugate of it. So conjugate. Because imagine finding the conjugate, this will become positive, and then minusing all of them will become this. So yeah. That's pretty much your answer, that one. Show that the Cartesian form of this relation is this. Not too bad. So let's do that. So because it's too much, we have to show some working out. So we want to first let z equals x plus yi. And then sub those in. So x plus yi. X plus yi. Minus 2 plus 2 root 3i. And putting everything together, so x plus yi. So x minus 2, y plus 2 root 3i. So it'll be the square root. That's not a nice square root. For this one, it'll be x squared plus y squared is equal to x minus 2 squared plus y plus 2 root 3 squared. Well, imagine squaring both sides. That square root just goes away, so it'll just become x squared plus y squared equals. And now let's expand these over here. So that will be x squared minus 4x plus 4 plus y squared. So imagine 2y 2 root 3. So 4 root 3. So it'll be plus 4 root 3y plus 2 root 3 times 2 root 3, which is 4 and 3. So plus 12. So having this, okay, we can cancel x squared from both sides and the y squared. So that's good. So it'll be 0 equals negative 4x plus 4 plus 4 root 3y plus 12. Because they're all, we have that 12 plus 4 is just 16. So let's write that down. So 0 equals negative 4x plus 4 root 3y plus 16. They have all common factor of 4, so we can take that out. So it would just be 0, negative x plus root 3y plus 4. And we want to show it's that. So we just need to bring it all to the left side. So that will be x minus root 3 y minus 4 equals 0. And we've just shown that. That's not easy. Sketch the lines represented by, so sketch the line represented by this and plot the roots of this. Okay, so what was the roots of those? It was negative 2, negative 2 root 3. So that's going to be negative 2, negative 2 root 3. So if I'm not mistaken, it's here. So that's 1. And the other one's the conjugate, so it must be over here. Yeah? Have a look at that. Remember this over here, let's double check it. So negative 2, negative root 3 is just 4 cis negative 2 pi, which is negative 120. Negative 120 and in that radius of 4. So 4, negative 120, so that's Yes, that's perfect. So, yep, and then the reciprocal. Those are your points. So, sketch a line and plot the roots. So, we've plotted those roots over here. And the line is this, and which is this, yeah? So, if I sub in, let's say, for x equals 0, what happens? We get negative root 3y, negative 4 equals 0. So, hence we get negative 4 root 3y, negative 4 over root 3. So, negative 4 over root 3, and what is that in terms of y-intercept? So let's use our calculator. So negative 4 over root 3. That's negative 2.3. So negative 2.3 is approximately here. Imagine it passes through this, and if I something like, for example, in this case, y equals 0, we get x equals 4. So that's good. So it passes through this. Because it looks like it's passing through this, wouldn't it also... It looks like it's passing through this. Let's check if it actually does pass through the point. Well, this point, again, remember it is negative 2 minus 2 root 3i. So it's just a point negative 2 root 3i. That's the point. So if I subbed in, for example, the point negative 2, let's see what comes out. X equals negative 2 minus root 3y negative 4 equals 0, which is negative 6. Root 3y, negative 6 over root 3. Imagine reciprocating, so rationalizing this. That will give us negative 6 root 3 over 3, which is negative 2 root 3. Aha, yes, it does lie on that point. So that's good to know. So it does pass through it. So we can now nicely forget about this point. We already have 2 points, so well, it's not actually something like this perfect. So that is that line. And yeah, so sketch the line and plot it. That's it. We've plotted it. The equations of the line passing... So wait. For equation of the line passing through the roots of this can be expressed as this, where a and b are complex numbers. Find b in terms of a. Okay, so it says the equation of the line passing through the roots. So these are your two roots. And imagine we're drawing a line through them. So if I just move this. Yes, so it passes through negative 2, which is just x is equal to negative 2. So if it passes through, it's just x equals negative 2. So, and we want it, so it can be expressed as this. All right. Okay, think of it in terms of, if you guys don't know, the perpendicular bisector can help us with this. So, what I'm thinking is, all right, what the perpendicular bisector tells us is like, for example, you know how this line, x equals negative 2, imagine that we have, let's say, this coordinate here and this coordinate over here, which is this equation over here, like this point over here and this point over here. And pretty much if we draw a line and the distance, the midpoint of them, a line passes through, which is our line, x equals negative 2. These 2 points are going to be in here, pretty much. That is what the perpendicular bisector is. So, for example, if we had, let's just give an example, actually, to really express that. If I had z minus 2 equals z minus 4. So this is telling us that the coordinates here are 2, 0. And this coordinate over here is telling us 4, 0. So what's 2, 0? 2, 0 is here. And 4, 0 is here. And if we draw a line between them, what is the middle point? It's that 3. It's that 3 over here. And if I draw a line inside that 3, that is what this equation actually tells us. And you can easily, you know, let z equal x plus y, and it's actually this equation, y equals 3. So that's a quick way to use the perpendicular bisector to help us with this kind of question. So let's use that to our advantage. So, okay. Okay, we can actually get many values. That's the problem with this question. We can use negative 1 and negative root 3. The midpoint between us gives us negative 2. We can also use 0 and negative 4. The midpoint will still give us negative 2. What about 1 and negative 5? That will also give us those points. So, so we can say that a, for example, our a value, let's say, let's look at this example. Let's say we're going to put -1 and -3. So for example, if we wrote z, we would write it as +3 z +1, because this will be -3 on 0, this will be -1 on 0. And yes, those are the points. Okay, that's good. And then the perpendicular bisector runs through them. So what are our a values? Pretty much in this case, our a value is -3. So when a is -3, b is -1. That's what we've just said. Let's try the other one. So other cases. So for example, now the next case we'll try is 0 and -4. So to write that z +4, which is just z. So it means that when b is 0, a is actually -4. Okay. And we just want to find an expression because it says find b in terms of a. I'm just trying to write as many equations as I can and see that kind of expression, and maybe find an expression in terms of b in terms of a. So let's say also point -5 and 1. So it will be z +5, z -1. Yes, so we can say that a is -5 and b is +1. So, okay, we have enough here. Look, I'll be honest, I cannot easily find the expression to write those, but what I can do is think of it like this. If I draw, because we want b in terms of a, imagine b is our y-axis. So b and a is our, and if we plot those points, so for example, -3, so if this is -3 and -1 is over here, so it's this point over here, then -4, and that's 0, so it's over here. And the next one is -5. It's over here. So it's pretty much this point over here that goes like this. What's the gradient of that line? And yeah, that's so we can find the equation. So in the long term, when pretty much a is equal to 0. So when is a equal to 0? Yeah, we can just find the equation using these over here. So for example, let's just pick 2 points, these two here. Remember, so your gradient of that line would be -1 minus -3, 0. Wait, oh my god, no. So -1 minus 0, -3 minus -4. So that will give us -1, 4 minus 3, which is pretty much overall -1. So the gradient's -1. Okay, and it is, yeah, and it's downward. So we can write it b is equal to -a, because a, in terms, like a is our x value. -a, and okay, and well, yeah, so, and what's our y-intercept? Well, what's our y-intercept, like plus c? Well, our y-intercept will occur when x is equal to 0, where in this case a is actually just 0. But when is a 0? What we can do is, wow, why am I taking very long? 1 mark for this question is it's such a hard question because, okay, y minus, okay, well, we have all these kind of points. Let's just use the y minus y1 equals mx minus x1 to find it. Like y, let's use point b0, which is this. Is equal to m, which is -1, x minus x1, which is -4. Y -x -4. So pretty much it's, wow, why did I make that? Yeah, so it's -4. So we have -4 here. All right. So yeah, would that express everything right? Let's check. So for example, b equals -a minus 4. Yeah, let's check that if that works. So if I subbed in, for example, a is equal to -3. So negative 3 minus 4, 3 minus 4, negative 1. Okay, that works. But we need to be careful. Oh, wait. A and B are elements of a complex number, so we can also have... What am I thinking? It's not just this. It could be also this point over here. Like, yes, it could also be this point where these two here, and it will still cross that. So what's... Like, let's pick these two coordinates over here, for example. Well, this coordinate over here would be what? It would be... pretty much just... In this case, it will be I. So it will be just I. And so that coordinate is just I. And whereas this coordinate over here is going to be negative 4 plus I in this case. So let's sub that in. Does that make sense? For example, let's check. So in this case, if hence we can write this, like for worrying it's Z would be Z minus negative 4 plus I equals Z minus I. So what are our values? So our A value is negative 4 plus I, and our B value is just I. So let's check if that equation also makes this sense. Like, does this equation also include ductwork with that? Let's check. So if I subbed in A, so B is equal to negative 4. So A is that. So negative 4 plus I minus 4, which will give us 4 minus I minus 4, which is negative I. But we have positive I. So if that is that, doesn't that mean that this has to be a conjugate? That A has to be a conjugate? Let's try to check that if that works again. So now let's do that. So negative, what's the A conjugate? It's just negative, oops. It'll be negative 4 minus I minus 4. So 4 plus I minus 4. And yes, now it gives me I. But I want to make sure it still works. If it still works in terms of these over here. If I sub in, like, for example, well, the conjugate of this, because it's a constant, we don't have in terms of I, it's just going to be negative 3. So it's just... like, 3 minus 4, which is negative 1. So that actually works. Yeah, that's your equation. Wow. I'm not going to be honest. I'm going to be honest with you. This question is very, very long. Especially for 1 mark. I would not put the work in. 1 mark for a rubbish question like this. Especially how hard it is. And the critical thinking that you need to think about is... It's not worth it. So... What about B? Find the area of the major segment bounded by the line passing through the roots of this. So... Yep, so that line... and the major arc of the circle of this. So it has a center of 0, 0, and it has a radius of 4. So I'm just going to rub everything off here now. I'm not going to use it. I'm going to redo this whole thing. Okay, so we know it passed through this here, and it passed through this, and this is a straight line. We also have a circle with a radius of 4, and it passes through the center, so it looks like this. Oops, did not draw. Why is it? Ooh. Okay, something like that. That's a beautiful circle. So we have, of course, we have the minor segment and we have the major segment. So we want that major segment. So this area over here. That's very easy because this isn't actually, it's a question that's similar to the sample paper. So to find that is what I'm going to do is I'm going to find, first what I'm going to do is actually find the whole area of that whole circle and then find the area of that minor segment and minus it from the whole circle, which gives me that major segment. So let's do that. So what's the first area of the whole circle? It's going to be pi r squared. So pi, well, r in this case is 4, so it'll be 6. So 4 squared is 16, so which is just 16 pi. Now to find the minor segment for this, in this case, this is what we're going to need. We're going to need the theta here, and we're going to need the radius. Well, the radius is just 4, and the theta is, if I'm not mistaken, each of these over here is pretty much 30 degrees. So if this here is 30, so imagine that this is pi on So if this is, sorry, if this is 30 degrees over here, and that's 60, and then 120. So the theta here is 120 degrees. And we have the r. So remember, if you guys don't have it, this formula should be put in your exam, in your bound reference. It's very important because it's always coming up in exam 2, and it is the segment formula. So the area of a segment, which is area is equal to half r squared theta minus sine theta. That's your actual thing. So, for example, in this case, what's the area of that segment? So that minor segment. So this will give us the area of this over here. It'll give us this area over here. So 1 over half. So r is 4. So 4 squared is 16. Theta in this case, we said is 120. So what's 120? It's just so it's pi on 3 2. Yeah, so it's 2 pi on 3 if I'm not mistaken. Yes. So 60. Yes. So we can write it as 2 pi on 3, that theta, minus sine 2 pi on 3. And yeah, so this area, what is that? And pretty much this area minus, so this overall 16 minus this whole area over here should give us our answer. So I'm just going to put them all together. So for example, I'm going to take this, bring it over here, put a minus symbol here. Okay, and let's find that area. So we're saying 16 minus, 16 pi minus half 16, 2 pi on 3, so 2 pi on 3 minus sine 2 pi on 3, this thing over here. Enter, and we get this. So yeah, it doesn't say to give in decimal places, so we have to write the whole expression here. Let's write that down. That's 32 pi over 3 plus 4 root 3. Done. Question 5. On a particular morning, the position vectors of a boat and a jet ski on a lake 10 minutes after they have started moving are given by these. Okay. And so this is the boat, the position vector of boat and jet, respectively for t is greater or equal to 0, where the distances are measured in kilometers. The boat and the jet ski start moving at the same time. The graphs of their paths are shown. On the diagram above, mark the initial positions of the boat and the jet ski, clearly identifying each of them. Use arrows to show the direction in which they have moved. All right. Okay, so let's try to find the position of the boat. Now, one of the best ways and the easiest way is to okay, what is the position of the boat initially? So at 0. If we put, okay, so then what's that? So if I sub in cos of 0, which is 1, so what's 1 minus 2, which is negative 1, so that's going to be negative I. And if I sub in, again, 0 to sine, which is just, 3 in this case, so it'll be plus 3j. So our coordinate is negative 1, 3. So negative 1, 3 is this one over here. So this eclipse in this case is the boat. So we'll write it as nicely R of B, so the boat. And what's its path? Well, think of it. At time equals 0, and then what about at time equals, well, in this case, because there's cos and sine, we'll write, what's the time at at pi over 2, for example? What happens, what's the time at pi over 2? Like, what path did they go to? Let's check that. So what's R of B at pi on 2? So we're saying 1 minus 2. What's cos pi on 2? That's 0, so it's just 1. Right? And if I subbed in pi on 2 to sine, it's 1, so plus 4j. So the coordinate is 1, 4. And what's that 1, 4? It's over here. So imagine we started over here and we ended over here. What is the movement? Well, it's actually clockwise. So just drawing arrows that are going clockwise show us that path. Done. And we do the same for the next one. So let's do the same thing. When does it start? So at what's r of j of 0? So if I sub in, 0, we get I. If I sub in, cos 0 is just 2 minus 1, which is 1, which is j. So 1 on 1, which is over here. So this is where it starts. That's where the jet starts. And let's see the movement. So if I said r of j at 1, actually pi on 2, because it's in terms of circular functions, so it's much easier to use that. What happens? If I subbed in cos pi on 2, that's 0, so that'll be just 1. And, sorry, that's the wrong equation. What am I doing? Okay, so r of j is, if I subbed in 0, pi over 2, so what's 1 minus sine pi over 2? Sine pi over 2 is 1, so that'll be 0. Okay, and so if I subbed in pi, so 2 minus, so cos pi over 2, which is 0, is just 2, so we just get 2j. 2j is over here. So, okay, so if we come up from here and we moved up here, we are actually, again, moving clockwise in this direction. So, yeah, we've just shown with arrows and what directions they move, and yet when they start. All right, that's it. Question B. Find the first time for t is greater than 0 when the speeds of the boat and the jet skis are the same. Okay, that's easy. Well, if we know the position vectors, for example, the boat position vector, well, the speed, it's going to be just the derivative of it. And because we're talking about speed, not velocity, we're going to have to find the magnitude. And we're talking about when are they the same, we're going to equate them. So the same for the jet. For example, for the jet. Let's do that. So yeah, find the first time when the speeds of the boat and the jet are the same. Let's do that. So actually, let's define them as vectors in our calculator. So calculations are very easy. So r of boat of t, we'll define them as 1 minus 2 cos t, and so 3 sine t, and r of jet of t is going to be defined as 1 minus sine t, 2 minus cos t. And we get these, okay. And again, so we want to find the derivative of the first one. So the derivative, or in terms of t, sorry, of r of b on t. So what's r b of t, which gives us this. And what's the derivative of the same, but for j? This. So we got the velocities. Now we just need to find the magnitude of them, which gives us the speed. So to find the magnitude, it's just the norm of this, which is that, equals the norm, the magnitude of this. And then we solve answer, comma, t, given that t is, let's say it's between 0 to pi, 0 to, so t is between, because it's in terms of cosine, so to pi, let's say. Enter, and we get, okay, t equals 0 and t equals pi. But we know that t equals 0 is not included because it's saying t is greater than 0, so t equals pi. Yeah, that's the first time at which the speeds of the jets are the same. So let's write everything that we know down. So we are solving. So 3 sine squared t plus 1 equals 1. Hence t is just equal to t equals 0 and t equals pi. Hence t equals pi. Yeah, that's it. So that's the first time. T equals pi. Next question. State the coordinates of the boat at this time. Nice and easy. So state the coordinates of the boat. So easy. So let's go on. What's r of b of this time, which is just pi? It's just 3, 3. So 3i. Let me write it nicely. So 3 of boat at pi is 3i plus 3j. That's it. Write down an expression for the distance between the jet ski and the boat. Okay, so let's go on a calculator. the distance. So we want the distance between the jet ski and the boat. So the jet ski is Rj of t minus, so the position of the jet ski minus the position of the boat, that is the distance. That's actually the displacement, so the change in position between them. But because we want the distance, we want the norm. Remember? It's norm, and it gives us this whole thing here. This overall here gives us the distance. This is an expression for distance. So let's write that down. So distance is going to be, it's a very long expression actually, but so it'll be 3 cos squared t plus 2 minus 2 sine t, and it's been actually, so it'll be plus cos t 2 minus 2 sine t plus 2 sine t plus 3. That's it. That's an expression. Find the minimum distance separating the boat and the jet ski. Give your answer in kilometers. Okay, nice and easy. So we have the distance formula. We just go menu, calculus, minimum of this whole thing over here. Comma t, where t is between, we said 0 to pi. Let's keep that still there. What do we get? T equals to pi. So we get the minimum. Wait, let's be safe actually. Let's call it like, I don't know, like 2 pi. Or maybe, I don't know, 4 pi. Something very big. Enter. Aha, so okay, makes sense. We need to be careful. T equals pi. Well, if I go up, wait, because I let it, these t equals pi. What about if I let it equal to like 4 pi? Yeah, but t equals pi is the second one. So that's good. That was good. And this one's that. Yeah. I just want to be sure. So at this distance, so at this time is where the minimum distance occurs. So again, what's the distance formula? What we did was, it's this one over here, and we put that time in there, and it gives us this. So to write to 2 decimal places, that's 0.33 kilometers. Okay, on another morning, the boat's position vector remained the same, but the jet ski considered starting from a different location with a new position vector given by this. So it changes, where t is greater or equal to 0, where a is a real constant. Both vessels start at the same time. Assuming that the vessels would collide shortly after the starting time, so after starting, find the time of the collision. So we want to find the time and the value of a. Okay, we got this new value, r of t. That's the jet ski. So, alright, so if we know that they're colliding, for the collision to happen, their positions must be equal. So r of t in this case, which is the jet ski, should equal to rb, the boat, of t. They must pretty much be equal if they collide. So let's actually define the new one. So r of t, which is the new jet ski one, which is the vector 1 minus sine t, a minus cos t. Okay, we get this, and we're saying what's r of t equals rb of t. It gives us these two equations. And yeah, these are two pretty much simultaneous equations. Let's write them down. So equation 1 is 1 minus sine t is equal to 1 minus 2 cos t. And your second equation is a minus cos t equals sine t plus 3, and we just use our simultaneous equations. So go on menu, go to algebra, solve simultaneous equations. We have two equations, and we want to solve for a and t, because we want the time also. So this one over here, this one over here. We want to be careful. We want to say the t is between, again, t is between 4 pi, something that's very high. And, okay. So we get these. So these are pretty much a lot, but we're only taking the first ones. We should only take, we're only taking the first ones. As, assuming that the first collides shortly after the starting point. So the first one is pretty much, that's when they collide, after the starting point. So imagine that they start and they collide straight away. So it would be this over here. It would be the first one. So actually ignore the other ones. Yeah, so we get this over here. So let's write them down. So the time is, pi over 2 minus tan inverse half, and A is equal to 3 root 5 plus 5 all over 5. That's it. So we found A and the time. But I think in the exams, they don't like it in terms of this, because this is, you know, CAS syntax. So just change it. We want to change it into a nice form, like an actual beautiful form. So if you're too confused to do that, for example, what does this actually represent? Remember, this is an angle and pi over 2. So imagine like drawing this. Okay. Imagine pi over 2, which in this case is this over here, minus an angle. So let's say here. So imagine this is pi over 2, and we're minusing an angle like this inside here, which is that tan, 1 over 2, to get this angle here. So, for example, this here, pretty much, in other words, this is your time here. This is your time, your t. And this is the angle that we want. Now here they're saying pi over 2, which is here, minus here, which in this case, this angle here is tan inverse of a half. So tan inverse of a half, pretty much. And to make it simpler, we just need to find this over here, this t value, which is much simpler. So to find that t value, just imagine like breaking it down. Like, because tan, in this case, is tan inverse is 1 over 2, it means that opposite, in this case, our opposite is 1, and our adjacent is 2. So it means this over here is 1, and this here is 2. So forgetting all about this, and using this, we can calculate t value much easier. So t is what? So the angle t is what? It's the tan inverse, because it's opposite, which is, in this case, 2 over 1. Which is, yeah, tan, so t equals, let's write that here. T equals tan inverse of 2, pretty much. And that's a much simpler way to write that in terms of, and let's double check if that's true. So for example, if I take this over here, is it equal to the tan inverse of 2? True. So that's great. So these are the two answers. Question 6. Hopefully this is the last question. Wow, it's such a long exam. Okay, question 6. A dairy factory produces milk in bottles with a nominal volume of 2 liters per bottle. To ensure most bottles contain at least a nominal volume, the machine that fills the bottles dispenses volumes that are normally distributed with a mean of this and a standard deviation of this. Find the percentage of bottles that contain at least the nominal volume of milk. So we want to find... Okay, so what we want to do is we want to find the probability. Let's say X. We want that contains at least. So at least, what's the nominal volume? Nominal volume is 2 liters, because they're all in milliliters. It's just pretty much 2,000 liters. 2 liters is just 2,000 milliliters. Produce milk in bottles with a nominal volume of 2. So that's the nominal. To ensure that most bottles contain at least the nominal volume, the machine dispenses this and that. Okay, and these are your mean, and this is your standard deviation. So yeah, we can, using our calculator, go on menu, go to probability, go to distributions, and we can just go to inverse not CDF. Our lower bound here is 2,000. Imagine going to infinity. Our mean in this case is 2005, and our here is 6, and we get this. Yeah, so when it's greater than that, it's that. To 1 decimal place, 0.8. Pretty much. Yeah, so to 1 decimal place. Wait, find the percentage of the bottle that can percentage. Wow. Yeah, so if we find the percentage, it's just correct to 1 decimal place. Okay, we just need to multiply this. Sorry, we just need to multiply this by 100 then. That gives us this. So to 1 decimal place, that's 79.8 Correct to 1 decimal place, yeah. Okay. Bottles of milk are packed in crates of 10 bottles, where the nominal total volume per crate is 20 liters. Show that the total volume of milk contained in each crate varies with the mean of this and a standard deviation of this. Okay, so, for example, a crate contains 10 bottles. So imagine bottle, you know, until 10 pretty much. So if we wanted to find pretty much plus ... you know, until we hit 10. So if we wanted to show the total, like the expected value of C, the crate, so for example, the expected value of the crate, imagine like using your formula, it's just going to be expected value of B plus the expected value of B, like 10 times. So it's just going to be 10 times the expected value of B, which in this case is 10. What's our B? Our bottles. We said that it's this one over here. That's your mean. So 2005, which gives us 20,050 milliliters. That's good. Same thing with the variance. So if we want the variance of C, it's going to be, you know, the variance of B plus the variance of B, which is again 10. Pretty much is going to be 10 variance of bottles, which is just 10. What's the variance of that versus the standard deviation? Imagine squaring it, so it's 36. Multiply by 36, which gives us 360. And imagine to get the standard deviation of C, it's just the square root of 360, which is just this over here, which is 6 root 10 milliliters. And we have just showed them. That's it. Perfect. Find the percentage correct to 1 decimal place of crates that contain at least a nominal volume of 20 liters. So we want to find the probability. So contain the crate. So find the percentage correct to 1 decimal place of crates. So you can see that contain at least a nominal volume, which is 20 liters, which is 20,000. And we already have the mean and the pretty much this. So let's actually just 6 root 10 into decimal. So let's copy that. Go to calculus, probability distributions, normal CDF. So we're saying 20,000. And we want to go to infinity. So your mean is 20550. And this is that. Enter. Wow, didn't get anything. Let me do it again. 20050. Sorry, what am I doing? So lower bound is 2,000. 200,000. Wait, is it 200,000? 20,000, sorry, 20,000. And your upper bound is infinity. Your mean is 20050. And this is that. Okay, and we get this. In terms of percentage, remember, we want it in percentage, and that gives us this, and we want it correct to 1 decimal place. So 99.6%. That's that. And these are your 2 last questions. So 3 marker. Regulations require at least 99% of the crates to contain at least a nominal volume of 20 liters. Assuming that the mean volume dispensed by this machine remains 2005 milliliters, find the maximum allowable standard deviation of the bottle filling machine needed to achieve this outcome. Give your answer in milliliters correct to 1 decimal place. So have a look at this. You want to have probability. The regulation require at least 99.9% of crates to contain at least the nominal volumes. So, okay, so we want crates to be at least the nominal volume, which is, again, 20,000. And we want this to be greater or equal, because we want it at least to be pretty much, we'll write this as 0.999. And so, so we're still using the expected value of this, and we want to find the standard deviation. Wow, 3 marks. Wow. What do I do here? What can I do? So, because I'm just having a blank now. Let's think. So, assuming that the volume spanned by screens, this find the maximum allowable standard deviation to achieve this. All right. So, what I'm thinking is, okay. So, what can I do here? Okay, so when we were doing normally, so if the machine remains 2,500, it means that each crate still has this much thing here. So imagine changing this to probability of Z. Actually, just let's change this to probability of Z. Standard number distribution. So it'll be 2,220,000 minus 20050 over our new this is our new standard deviation that we don't know. But this is the standard deviation of the crates. But remember, we want the bottle. So we'll keep that crate one here. So this must be greater or equal to 0.999. Now, we can pretty much write. So if I was just drawing a nice curve here, say we're saying this. So we can write this as actually 1 minus the probability of Z less or equal to, well, in this case, it's going to be negative 50 over this is less or equal to 0.999. And if I minus 1, so it'll be 9 minus probability of Z, it's negative 50 over this. It's greater or equal to negative 0.001. And if I divide them both by negative, what's going to happen is that the sign of this one will change. So it'll be less so 0.001. Now, this is an easy expression to kind of simplify using our CAS. So, so go in our menu and go to probability distributions in normal, this. If we say that the area is 0.001, press OK, we get this. And if we equate this to the negative 50 over O, which is our standard deviation, solve, answer, comma O. And this here, okay, we got O. We got not O, but we got the standard deviation to be 16.18. But be careful. This is not our standard deviation of the bottle machine. We want the bottle filling machine. This is the pretty much the crates. And so, okay, if we got that, how do we go back to this? Have a look at this formula. We use this formula over here. So imagine squaring this to get, so this is, so pretty much this over here is the standard deviation of the crate. So we want to find, so if we find the variance of it, of the crate, it's just squaring it. Imagine squaring it. So squaring this over here, we get, 261.79, 27. So we squared it, and so, because we're just using this formula, again, we're just going backwards pretty much. So again, we know that variance of C is equal to 10 times the variance of B. And we want that variance of B, so it will be 261.7927. It will also be divided by 10, and that will give us the variance of B. And imagine square rooting that whole thing, and that will give us the standard deviation of the bottle filling machine. So standard deviation, your overall is what? Wow, this question is very long. So that goes here, divided by 10, enter, and we get 5 point, to 1 decimal place, that's 5.1 milliliters. Is that right? Is that in the right units? Yes. Wow, that is such a hard question. Yeah. Next question. And 2 marks. A nearby dairy factory claims that the milk dispensed into its 2-liter bottles varies normally with the mean of this and a standard deviation of 2. When authorities visit the nearby dairy factory and check the random sample of 10 bottles of milk, they find that the mean volume is this, so it's actually decreased. Assuming that the standard deviation of 2 milliliters is correct, carry out a one-sided statistical test and determine, stating a reason, whether the nearby dairy claim should be accepted at the 5% level of significance. Okay, we just actually need to find this p-value. So the p-value for this statistical will be the probability, where x, because we're claiming that here it's less, it's become less, so it will be less or equal to that 2004, given that your mean is just normally 2005. So we can write that as z is less or equal to 2004 minus 2005 over your standard deviation. But this standard deviation is going to be s, which is your 2 over square root of how many bottles? We take 10 bottles, so it's 2 over root 10. So this, and that is going to give us a p-value. So let's just simplify this. So we're saying -1 divided by 2 over root 10. We get this. Control Enter, and we get this. And we go to menu, probability distributions, and we go to normal CDF. And we're saying that this is that. Using normal distribution doesn't work. Let's do it again. This is that. Okay, and we get this. So this is our p-value. So our p-value is 0.056. Okay, this is the case. We know that if p is less or equal to your level of significance, which is 0.05, we reject the null hypothesis. If p-value is greater or equal to 0.0, is greater, not equal, sorry, to 0.05, we accept the null hypothesis. In this case, it is actually greater. We can see that p is greater than 0.05, meaning what? We accept the null hypothesis, meaning that, so say, let's have a look at this. So if I just take this and delete these here. So we want to accept the null hypothesis, assuming that the standard deviation of carry out a normal set. So this is our null hypothesis. It's just like we're saying that the dairy factory claim is actually true. So, a nearby factory claims that the milk. So we say that the dairy claim is true. That that the bottles vary with a mean of 2005 milliliters, because we are accepting our null hypothesis. So remember, our null hypothesis in this case was 2005, and our alternative hypothesis was less than 2005. So we are accepting our null hypothesis in this case. And that's it. I hope you guys enjoyed this video and learned something. I just want to say thank you guys for watching this video. Please make sure to like and subscribe and share this video with your friends. It will be a great pleasure. Thank you guys for watching and have a great day. Bye-bye.